Hello and welcome everyone. This is going to be an introduction to WebGL tutorial. This is going to be more or less a crash course. We're going to go as fast as possible through this just to get the basic setup so that everyone has an idea of how everything actually works. So let's get started. Firstly, you want to just have your HTML code, just have it set up, a very basic template. And then you want to add in your canvas element. You can give it any width or height you want, but make sure you remember what the ID is called. Then you want to add in your JavaScript file that we're going to be using, and then inside the JavaScript file we actually want to get the canvas element that we previously created in the HTML. Then we want to get the context. We're going to call it GL. The context is going to be WebGL2. Please note there's a very big difference between WebGL and WebGL2. There's actually other contexts that you could also get, but we're only going to be focusing on WebGL2. Then we want to create the shader. We're going to start with a Vertex Shader. So the Vertex Shader, you always have to have the first line in this way, where you're going to have hash version 300 ES. Anything, you cannot have a space or comment or anything before this line. Make sure it's always exactly like that. Okay, then we're going to create the main function, and first of all we're going to have whatever we want to send to the Vertex Shader. In this case we're going to have a vector 4 a pos, which is just going to be a vector, a 4-dimensional vector for the positions. Then we're going to have the GL position is going to be equal to our input attribute. Please note that this GL position is part of the Vertex Shader. You have to name it exactly as is. Where the shader is now going to know, okay, so this is going to be the exact position that you want to have your point, your vertex. It's going to be the position on the screen itself. Then we're going to create the Fragment Shader. We also have to have it the exact same as the Vertex Shader, where we start off with the very first line with hash version 300 ES. It also has a main function, and we're just going to have a precision, which this is just going to be it's going to be the medium precision float, which is just saying what it's basically just a default, because there is no default, so we're just going to set this manually. Then we want to have an out vector. Okay, so anything that's output from this shader is going to be the color of the pixel itself. You can have it named anything you want, but it's only going to be a single vector 4 that's going to be output for the color. It's going to be RGB and then alpha. So we're just going to have some arbitrary color. We're just going to have it as so. And then we're going to now create the shader from these sources. So firstly we're going to pass through the context, we're going to pass through the type of shader that it's going to be, and then we're also going to pass through the source, which we've just coded there up at above here. Okay, so the shader, we're going to get the shader, we're going to create the shader from the shader type, and then we're going to we're going to add the source to the shader, and then we're going to compile the shader. And often you can get errors, but in this case we just want something simple, so I'm just going to put a to do over here to handle errors. Usually you would want to code this in, but we're going to keep this simple. And then we're going to return the shader that we've now just created, compiled, and then okay, so that's just for the function. Then we're going to create our very first shader. We're going to create the Vertex Shader by passing in the parameters. Notice the gl.vertex shader. That's specifying which type of shader we're actually going to be creating over here. Then we're going to pass through the source that we created above, and then we also want to create the fragment shader in the same way, just with fragment shader instead, and we're going to pass through the fragment shader source. Then we're going to create the shader program. Now the shader program is going to take in the GL context, the vertex shader, and the fragment shader. So we're going to create the program firstly, then we're going to attach the shader to the program, both of the shaders. So yeah, it's going to be the vertex shader and the fragment shader, and then we're going to link the program. And then notice we also want to handle errors over here. We're not going to do this now, as we said above, and then we're just going to return the shader program. So the shader program is, we're now going to use that function to actually create the shader program, and then we want to get the positions that we pass through in the vertex shader, which we called a pos. So now we're going to get the attribute location for it. Okay, and now we have to create a buffer to be able to store the data onto it. So we're just creating the position buffer, and let's just scroll down. Okay, and then we're going to create the vertices that we want. We're going to just pass through 3 different points. It's going to be at point -1, 1, -1, -1, and 0, -5. Those are just going to be the 3 points that we want to create our triangle. So then we create the buffer data. We specify that it's going to be a float 32 array, and then we're going to pass through the vertices, and we want to say static draw. Now static draw just means that we're not going to be changing the vertices much. Okay, and now we want to create a VAO, and now the vertex array is what's going to contain the buffer arrays. We can have multiple. In this case, it's only going to be one example, but it's always good to have the VAO. It's new in WebGL2, and it is incredibly useful. Like the processing speed is way faster, but you would only notice that in the future. So then we want to bind the VAO to, so we're going to bind the VAO, and then we want to enable the vertex attribute array, so the VBO, which was pos, which is going to be the position. So now it's bound, now we have the position bound to the VBO, which is bound to this VAO. And then we want to specify how we're actually going to output this data, or how we're going to read this data, sorry. So we're going to have the iteration, we're going to have 2, meaning there's going to be 2 points, and we want the data type to be a float. We're going to, we're not going to normalize it. You will learn what normalizing is later on. The stride just means how many entries in the VBO we're going to read, or we're going to skip, sorry, and we're not going to skip any. And then the offset is just where we're going to start, so we're going to start on the very first entry. Okay, and then we're just going to chuck that into the vertex attribute pointer, so now it knows how to read the data. And then now we can actually just start drawing it. So we're just going to say the viewport that we want to use. We want to use the canvas from 0, 0 all the way to the whole width and whole height. And then we want to clear everything, including the buffer bit. This is just basically a refresh. Then we want to use the program that we created, and we're going to bind the vertex array object. Keep in mind we haven't unbound it, so we haven't unbound it, but this is just a safety measure. And then we want to draw the array. That this is now going to be the VAO that we've bound to. We're going to draw in triangles, and there it is. now we have our triangle. So next up, what do we want to do? Let's say in the shaders, we actually want to have the color represent the position that it's at. So we're going to have color is equal to a underscore pos, and then we now need to send it to the fragment shader. So we're going to have this output from the vertex shader, and then we're going to have it input into the fragment shader, and now we can actually use it, and we're going to say the output color is going to be equal to the color that we pass through from the vertex shader. And there it is. Notice how it actually blends the color. This is actually where the shaders are useful. The fragment shader, it takes in whatever points that you have, and then it interpolates in between for each pixel. So as you can see, the top one is going to be fully green, the bottom left is fully black, and the bottom right is fully black as well. And then it just interpolates the data from there to actually give the color. So now let's actually add, let's shift up the triangle by 1. So in the vertex shader, we're just going to push it up by halfway through the object, and then notice how we actually shifted it up. Now this is actually where the vertex shader is useful. So now we already busy using the shaders just to manipulate what we're seeing. So we're not actually changing where the points are, we're just changing how we're drawing it. But notice how the color is just plain, it goes from green to black, but now that the top left is going to be a red, green, blue. With the red, that's going to be the X position, but notice that now we're quite far over onto the X position, especially for the point way on the right, but it's not red. This is because we only added 1 to the GL position, but we had the color equal to a pos instead of GL position. So it's not being represented properly. So we actually just want to have the color equal to GL position. So now it's going to include, so now we're going to pass through that into the fragment shader, and now it should have the color red. So I hope this introduction has been useful. Give a comment, and I hope you've learned something.